Good morning, everybody. Welcome to the video solution for problem 8 from Super Quiz 3. So here we are asked to compute the Maclaurin series for the square of the cosine function. And, well, we know already the Maclaurin series for the cosine function, but if we want to square it, well, one thing you could do is write down the individual Maclaurin series and then multiply them out. But this feels like a lot of work. This doesn't feel so fun. So instead, we want to use a trig identity. And in our homework, we looked at a trig identity, which said that if you want to know the sine squared, and you want to write it in terms of something without a square, you can write it as a half 1 minus cosine of 2x. And this will allow you to use the cosine Maclaurin series in order to find a Maclaurin series for sine squared. So here what we're asked to do is to modify this trig identity so that we can compute this Maclaurin series for cosine squared instead of sine squared. So in order to do this, well, we have sine squared and we want cosine squared, but there's a very nice relationship between these things. So we know that cosine squared is equal to 1 minus sine squared. And now we can use this given trig identity and write this as 1 minus, okay, 1 half 1 minus cosine of 2x. All right, we'll do a little simplification. First, the constant, we have 1 minus a half, which will be a half. And then, let's see, we also have minus a half minus cosine of 2x. So minus minus is plus, and we have a half cosine of 2x. So plus a half cosine of 2x, or if we prefer, a half times 1 plus cosine of 2x. Hey, that's not a huge difference. All right, just turn this minus into a plus. Great. So now we can write down our Maclaurin series for cosine of x. So this will be the sum from 0 to infinity. We have an alternator. We're going to get the even powers of x over those even powers factorial. And so if I want to get cosine of 2x, I'm just going to replace my x by 2x in our Maclaurin series. So cosine of 2x is going to be the sum from 0 to infinity. We have an alternator, and now instead of x to the 2n, we'll have 2x to the 2n, and again over 2n factorial. All right, so as is pretty common, we'll break this up into two different pieces. So we keep everything in front, but now I'll have 2 to the 2n, and I'll write that over 2n factorial, and then times x to the 2n. All right, so now in order to write down cosine squared, I just use the identity. So this will be 1 half. Actually, it might even be better to use this one. We can use 1 half plus 1 half cosine of 2x. And now I can just replace cosine of 2x with its Maclaurin series. So this will be 1 half plus a half. Okay, that 1 half is going to come inside the summation. And when it does, it'll get rid of one of these powers of 2. So we'll have n goes from 0 to infinity, negative 1 to the n, 2 to the 2n minus 1 over 2n factorial times x to the 2n. And there we go. We have a Maclaurin series for cosine squared of x.